So we're starting a new unit, and it is, our new unit is called Number Sense Enumeration, unit number 2, okay? Last one was patterning in algebra, now we're in number sense enumeration. So how we represent numbers, how we talk about numbers, how we see numbers, and how we work with numbers, okay? Some of the stuff is review, and most of the stuff we're going to do today is review. Some of the stuff that we've already talked about in our last unit, patterns in operations, multiplication, division, addition, subtraction. That's also what we're going to be talking about in some of this number sense enumeration. For today's first lesson, we talk about representing integers. And we know integers is really just a fancy math word for numbers, right? So how we represent, how we see numbers, that's what we're talking about today. There's really 3 ways that we're going to talk about. The first one is place value, or what we call standard form. So when you see a number in the most standard way possible, right, that's what we call standard form. If you see numbers like, for instance, this one, 573498123 decimal 468, right? How you see the number represented on a house, a 911 sign, a price, right? These are all standard forms of numbers, okay? Standard form is something that you've been doing for a long time. It's not anything new. When you were smaller, you might have seen that these were grouped into houses, they used to call them. Millions, thousands, hundreds, right? But each spot within the house has its own name. Generally, we look at whole numbers, so we're not looking at any decimals yet. When we look at whole numbers, we start with ones, tens, hundreds. Then you get into the thousands, 10,000s, 100,000s. And Havana, we got millions, 10 millions, 100 millions. You can see the pattern. After the first one, ones, tens, hundreds, then you've got the house, in this case thousands, then 10 house, 100 house, or 10,000, 100,000. The house, millions, then 10 millions, 100 millions. The next one would be what after millions? Billion. So you'd have billion, 10 billion, 100 billion. Trillion, 10 trillion, 100 trillion. Okay? So there's a pattern to how it works. Okay? And there's a pattern to reading numbers. So if we had this number here, we would say, as Addison knows, 123. Straightforward. 123. If we had this number plus this number, right? Whenever we read into the next number for thousands, we read the number in its house. So these 3, we always group the numbers into 3s. 3, 3, 3 for houses. This one we said we read as 123. Let's say we wanted to read from the 9 back. Okay? 9, 8, 1, 2, 3. We would read it as 98,123. If we had the 4, 498,123. So we read them with their 3 grouping numbers in their house, right? If you only had this, 8, 1, 2, 3, you would say 8,123. Every time you get to that break spot, you go back and you put the house in. So 8,000 or 98,000 or 498,000. Same when we're here, right? 3,073,573,000,000. If you wanted to read this entire huge number, stopping here because we're not talking about decimals yet, we would say 573,498,123. Right? So it always goes back to the house. If we were to put up other numbers, something like this. If we put up a number like this, what are we talking about? If you wanted to fill in the placeholder, it could look like this, right? So what are we looking at now when we look at this number here? How would we read that? Well, then this number is in what house? The thousands, right? So how would we read this, Jess?
56,478.
56,478, right? What about this? How would we read something like this? Georgia?
23,521,033.
Yeah. We don't have to put 100 in because there isn't one. 23,521,033. Right? So whenever we're reading numbers in standard form, every time we're getting to the break points, we have to go back and say the house word. Right? Every time we get to the break points. And those break points you see are those in between houses. There and there. Okay? So, we've got 573,498,123. How would we read this number? Someone other than Georgia and Jess. How would we go about reading this number? Think about our houses, right? And it's just a whole number, so there's no decimals. So if we go through and we look at our houses, what house is this? This is our millions, right? Thousands. This is our hundreds. So we would say 687,414,301. 687,414,301. Why don't we say 321? Why don't we say 321? Niels, why don't we say 321? There's no 2. We can't put a 2 in where there isn't one. It's just 301. Right? If there was a 2 there, Niels knows it would be 300. It would be represented by 321. So this is the standard way we deal with numbers. Okay? But lots of times you might go to the grocery store and you might see this. $4.99. Right? Well, I love it. Natalie says round it up. If we're trying to keep a running total of our groceries and how much it costs, yeah, I'd be like, okay, those strawberries cost $5. Okay, $5. I'm getting 2 of them, $10. There's $10 worth of strawberries right there. That's a great strategy, right? But let's talk a little bit about the other side to the decimal. Okay? Because when you have this as 0, it's a whole number. Any number, 301 is really 301.0000, right? But because mathematicians are super lazy, we know that. They come up with formulas, they do all kinds of lazy stuff. They're like, we're not going to write a bunch of zeros or even a decimal. We're just going to write 301. It's pretty much basic thing. But we know it's really 300 decimals, got infinite zeros that could go after it, right? We know that because we can have part of another number. So in this case, 573,498,123 decimal 468, we're that much farther to finishing with a 4. We're between our 3 and our 4, right? Because we have 573,498,123. That's a number itself. 498,124 is another number, right? And this is here part of the way towards that next number. So between all our numbers, so between 1 and 2, we've got a bunch of numbers that could go there. Because you could have, between 1 and 2, you could have 1.1, 1.2, 1.3, 1.4, 1.5, 1.7, 1.8, 1.9. And then you could have 1.11, 1.12, 1.13, 1.14, 1.15, right? There's a lot of numbers that could fit between the number 1 and 2 that are partial numbers. It's a whole number and part of another number, we like to say. So when we talk about numbers to the right of the decimals, they're only part of a number. It's not a whole number, right? So when we write them and represent them, we say tenths. It's got a TH because it's a tenth of the way to the next one. Or hundredths or thousandths because it's only part of a way. If we're writing, let's say, decimal 328, we say this as decimal 328 thousandths. Decimal 32 hundredths. Decimal 3 tenths. Okay? So in here we're looking at houses. Here right now we're just going back to where it is. So if I was to read this whole number, this giant big number here, not just the whole number, but the number plus the decimal, I would say 573,498,123 decimal 468 thousandths. Thousandths. Okay? Not any of this should be really brand new, right? This is stuff that we've been going over the last few years, but it might feel like, okay, that's how it works again, because it's been a little while, right? The other two ways that we talk about numbers, and these are pretty simple, pretty straightforward, right? The first one is just called expanded form. That's when you take your standard number, in this case, 56,073, and you break it down to the individual houses. So in this case, we start at the far side and we say, okay, 5 plus all the zeros, 50,000 plus, what's the next number? 6,000 plus 70 plus 3. So we're taking the number and we're expanding them into their individual spots. And that's expanded form. So if we had something like this, 123,406, it would look like 100,000 plus 20,000 plus 3,000 plus 400 plus 6. That's expanded form, right? We're saying all of these are the houses and the areas. We're identifying the different place values and putting them out there, okay? The last one, in which we represent integers or numbers, is in written form. Sometimes you'll see it. Oftentimes, if you're reading a book or an article or something, most of the time they're going to put numbers in written form. So you look at something like this, 785,426. And in written form, just like you would do in your head, 785,000, right? You could put a comma. 426. Exactly how it sounds when we talk it out. 785,426. Okay? So you're just writing out the words. Does anyone have any questions about how we represent these integers? We're going to talk a lot more about decimals later, right? And we're going to go through, we're going to talk about how that works with some rounding. I know we talked a little bit about it last unit. We talked a little bit about rounding, a little bit about addition, subtraction, multiplication, division. We're going to continue to do those. We're going to talk a little bit about fractions in this unit as well, which is really exciting for me because I love fractions. I love dividing stuff up. Okay? Anyone have any questions? All right, we're going to get into some questions.